You're muted.
Hello? Can you guys hear me?
Absolutely.
Awesome. Welcome. How are you guys doing?
Good.
Well, welcome everybody. Today is Mark's class zero Foundations of Programming. Uh, my name is Rogelio de la Garza, but you guys are more than welcome to call me Roger if it's easier on the tongue. Um, it's good to see that we have a good turnout. Hold on, give me a sec. Sorry, I had something playing in the background. Yeah, so welcome everybody. Go ahead and turn on your cameras, please. So if you made it this far, congratulations. You guys are going to be officially on the course. I'm assuming for the most part, all of you guys are here for the immersive program. So if you're sitting in this class, you can feel a little comfortable knowing that you're accepted and you'll be making your way through it pretty soon. The Foundations of Programming course, it was a course made for you guys, specifically service members, to tackle the difficulties that you guys go through upon your transition. We understand that, as we leave the military, chain of command can be a little difficult with trying to give us our allocated time to transition out. So, we create FOP to ensure that you guys are able to prepare yourself prior to starting your CSP or skill bridge, as some of you guys call it. A little background on myself. I myself am a veteran. I recently left the service sometime in like October timeframe. I'm a recent graduate of Copenhagen as well. I went through the full stack immersive program upon my transition. I served 8 years in the United States Army as a combat engineer. And I went through the exact same thing you guys are going through now. Upon graduating from Copenhagen, I volunteered as a TA to get some more time working with other software developers. And I was fortunate enough that I was offered a position with Copenhagen as the Foundations of Programming instructor. So here we are now. So I know the struggles that you guys go through as well. I got any Army in here?
Yeah,
No?
me.
Awesome. What'd you do, Joseph?
I'm a medic.
Medic? All right, cool. Anybody else? Okay. Yeah, so little disclaimer, I do have a kid, so if you hear him yelling here and there, please bear with me. If it gets too loud, just let me know, and I'll quiet him down. And I have a dog too, so you'll see him here and there too. FOP is gonna run Monday through Friday for the next 4 weeks. We're going to start at 5:30 p.m. sharp Central every single day, and it'll run up to 9 p.m. Upon completion of the class, I'll stay behind in case anyone has any questions or would like to discuss anything that we covered throughout the day that you guys would like to receive some more further explanation. Throughout the class, I do encourage you guys to please keep your cameras on. It makes it easier to teach when I can see some smiling faces, and also easier to gauge whether you guys are understanding the curriculum or if you're confused by the looks of the faces you guys make when we talk about some subjects. I do encourage you guys also to try to participate as much as possible. When it comes to coding, software development in general, the more you put into it yourself, the more you'll get out of it. How many of you guys are self-taught out here the last couple months? All right, for the most part, you guys, right? I myself was self-taught. I started off with a bunch of books. When I decided I wanted to transition into the software engineering world, I didn't know where to start. So I went to my nearest library and I got like 10 different books of all different types of coding languages. And I started learning all these different things, not knowing what I was doing, watching YouTube tutorials and whatnot. But you're gonna come to find or realize that, you can watch as many YouTube tutorials and you can hear someone talk about coding, but unless you're behind the camera or behind your computer and you're actually coding, you're not going to learn anything. So try to participate as much as possible throughout the lectures. I'll ask for feedback. You know, I encourage you guys to volunteer, give me your feedback. Leave the ego out the door. I believe that one of the things that we struggle a lot as software developers or aspiring software developers is that we're too afraid to make mistakes or to like show our code in front of other people because we don't want to look like we don't know what we're doing. And just know that you might not understand it, and someone else in the class might not either. And you voicing up and demonstrating your code will make a good teaching and talking point to learn from our mistakes. So definitely do participate, volunteer. The more you volunteer, the better. When I went through my software engineering bootcamp, I was the guy that was unknowing everybody else because I understand it, so I ask questions. But closed mouths don't get fed. So if you don't speak up and say, hey, so and so, I have no idea what you just said. It's not connecting. You're not going to understand. So please do participate. If you don't understand something, stop me in my tracks. I'll stop and explain it. Don't let me get 10, 15 minutes into the conversation and we're talking about something else and you have no idea what we just discussed and now you're lost. It makes it hard to catch up. I'm assuming every single one of you guys have made it through the pre-work. Did you guys do the technical check-ins with Guillermo? Awesome. Who here did not complete the install fest? Okay, 2 of you guys. Did you guys start it by any chance? Did you run into any issues?
I was running through it today, and I got caught up on the installing the database software. So
yeah. Cody, I see R Cody. Well, what do you want to be called?
Cody's fine. Yeah, Robert is my first name, but I go by Cody. Yeah, I can work on it tomorrow during the day. I didn't know I was supposed to do that today.
It's fine. It's no big deal. We'll definitely take some time later on and try to get it done. The reason we do the install fest during the pre-work, or it used to be during the foundations of programming, is because the moment you guys start your cohorts, the install fest takes a big chunk of your first week. So establishing everyone's virtual machines to ensure that you're ready to go and be able to work on the assignments is a big issue, because if you do it wrong or if you miss a step, you're gonna find yourself having issues later down the road, like let's say like a month and a half or 2 months in, and you're gonna have problems that you don't know what's going wrong with or why it's doing what it's doing, and you come to find out it was because you did the install fest wrong. So we'll do that separately, us three in a different window at a different time. But yeah, so let me go ahead and get started with our first lesson. If you guys check on Slack, you're gonna see that I have a couple links there posted on the Slack channel. One of the links there is going to be the class slides, and the class slides is a little bit misleading. It's more of a schedule or a guide of what we're going to be covering while we are going through the course. Go ahead and click that, open it up. I should have been used to it a hot minute. If you guys can see my screen, this is what your class slide should look like. I was editing it, so it's not perfect. This is May class schedule. You see here, to me Monday to Friday, 5:30 to 9 p.m. On top, you're going to see the GitHub repo. And if you click it, it will send you to the repository on our GitHub of the curriculum that we're going to be covering. You don't need this just yet. Who here is familiar with GitHub?
I've used it to install some things, but not much.
Okay, yeah, we'll definitely be covering that today, so you guys will get a little familiar with it. It's going to be very heavy. GitHub is very popular within the industry. So we'll use that to download our curriculum for the course. Here I have the first week already laid out for you guys of what we're going to be covering. you'll see the lessons that we'll be covering. At the bottom, we have YouTube videos. There's nothing there just yet, but throughout every single day that we go through FOP, I'm going to download the recording of today's lecture. It will be uploaded to our YouTube channel, and a link will be shared on this class schedule as well as the Slack. So you guys are more than welcome to go back, review any kind of the material that we covered. If you miss a step, or if you didn't show that day, you're able to go and rewatch it. And then on that subject, FOP is a optional course to take. It's not mandatory. I do highly encourage that you guys try to show up every single day, to maximize what you get out of the course itself. But if you guys have things come up, like we understand we all have our own lives, family, children, and social lives. If this happening or whatever, just give me a heads up prior to class. Hey, I won't make it, and no problem whatsoever. Yeah, I do encourage to try to make it for every single day. There's some things that once we get into like week 2 or 3 where it's very heavy on coding, and the material can become very confusing. So if you miss a day, you're gonna be lost the next day if you don't review the video. But yeah, here you'll find your YouTube video links that'll be posted on Slack. As we go, I'm gonna be showing some slides on my screen. If you'd like to follow along on your own computer, you'll have the links here too for the specific lessons that we're currently on, and so forth. Today, lesson 0, intro to foundations of programming. All right, so as mentioned before, the class schedule, make as many classes as you can. Like I said, you're only gonna get as much out of this as you put in. You guys are fortunate that you guys showed up here and are taking the time to go through FOP. Compared to a lot of your other peers, you're going to be miles ahead. The benefits of going through foundations of programming is that whenever you do run into some of the subjects that we're going to cover here, in your actual cohort, it won't be the first time seeing it. One of the main subjects we're going to cover is going to be object-oriented programming, which tends to be the biggest friction point for our students. And it's probably the hardest assessment you'll take throughout your course. We'll really dive into that and ensure that everyone here understands it. So, FOP will help you understand it better once you get into the cohort, so you don't struggle as much as other people. So instead of spending hours on there and trying to debug your code, you can spend more time actually coding and getting more out of it. All right, so bring any questions about the pre-work programming you might have. We'll make time at the end of the class for them. So as I mentioned, you guys are welcome to stop me at any moment if you guys are confused, if you want me to explain something in a different manner. I am Mexican. Spanish is my first language. So, sometimes I talk too fast, or I might not, pronounce some words correctly. If you want me to, reiterate what I said or explain it in a manner that makes sense to you guys, by all means. Some things are going to be a little bit difficult to understand. So I might draw it out for you guys. I know some people are visual learners, so if you want me to draw out for you, let me know, and we can, draw it out on the screen to give you a better understanding. We'll ask for feedback during and after this course on what, you felt, helped you out, what could be improved. And then at the end of your cohort, whenever you finish through the immersive program, you'll have a small survey as well to better improve the class for the people that come after you. The objective is to better prepare our students for our immersive program. All right, we want to increase the success rates of all our students. There are some students that do struggle specifically on the object-oriented programming part. So going through the FOP, especially week 2 and 3, will better prepare you for that and give you less of a headache. Machine setup. All right, so I'm tracking already. 2 of you guys still need to do that. We'll take care of that at the end of class. We'll try to get through your kinks. If not, we'll get Guillermo in here too. Guillermo is the machine setup wizard. But because, as I mentioned before, it used to be on the foundation of programming. Now it's been shipped over to the pre-work. We won't focus too much on this right now. Breakout rooms and installing. Right, so we like to take 10-minute breaks within every hour on the hour. Ensure you guys can go use the restroom, get a cup of coffee. Is anyone here not Central Time? Anyone like in some weird place like Europe? Okay, where you guys at?
Eastern,
Cool.
I mean, 1 hour, but
Okay, Eastern. Cody?
Same.
Okay. Yeah, it should be too bad.
Yeah,
but- Sam?
oh, just Eastern, yeah.
Okay. Well, good. Nothing too crazy. We had people like in Hawaii before or in Germany. And you know, that kind of sucked because they had to be up super early
Yeah,
to do
they
this.
over here also.
Raven, well, Raven, or how do you want to be called? Panlaki, how do you pronounce that?
Penlocky, you could call me Raven though.
Panlaki. That's a cool
Yeah.
name and very unique. Raven. It's like a superhero name. Yeah. So we'll take a 10-minute break within every hour. If you guys are struggling with the material and you need to break yourself, do say something and we can take a small little intermission so you guys can take care of what you need to do. Wake up, stand up, walk around. If you finish early, don't worry too much about this. We'll probably do a little bit at the end of class, but this is from the old material. Gotta rearrange the slides. All right, so running JavaScript, Python files, and VS Code. Are you guys familiar with VS Code? Who here has not used VS Code before? Okay. Yeah, I
Sounds
do recommend.
familiar. I think I've
Okay.
used it before, but years ago.
What do you use right now? Replit?
Replit, yeah.
Yeah. Our main curriculum is going to be based off of VS Code. So as you get a chance, do try to install it onto your computer. We're going to be everything that we do during FOP will be oriented around VS Code. It'll make it so much easier. So running your JavaScript and Python files. Who here runs their code in the manner as you see here on the screen? Do you guys right click, put run code? Who here presses the play button at the top right to run your code?
sometimes.
Yeah. Okay.
Sometimes I
Cool.
use my Control S. And I don't know, it all depends.
Okay.
I
And
think
we're gonna.
so Guillermo told me it was wrong.
Yeah. It's not the way you want to do it, right? So you know exactly what it's doing for you. So we're gonna discuss of how exactly we're gonna be running our code here. So this is the repo that is on the calendar. Don't worry too much about it right now. But you'll get to it later, right? But if we wanted to run our code, we can make something like example.py. We create a Python folder here, and we can print hello. Something very simple, right? Whenever you want to run your code, instead of doing the right click and run, right, or pressing the play button on the top right, you're gonna use your terminal for most of your commands here. All right, anything that you can do on your computer, you can pretty much do from your terminal. So start getting used to on running your code through your terminal. So you would do Python. If you did the install fest, you should have Python already registered as an alias. If you didn't, you have to do Python 3. So you essentially call Python and then the name of the file you want to run. As you run it, you'll see here on the terminal, it's going to run the code of the file I called, and it prints out its result. So refrain from doing the run Python or the play button. Most of the commands that you're going to be doing is going to be run through the terminal, and you just want to get used to the terminal as much as possible. That's how real software developers work. So that was a Python file. If you are familiar with JavaScript, it's going to be a little bit different. Console.log, hello. Instead of Python, you're going to do node and then your JavaScript file, and it'll give you something very similar to that, right? So as mentioned before, if you went through install this, you should just be able to put Python, if not Python 3. But for running all your files, you're gonna want to run them through your terminal, right? Learning how to code. All right, so we're gonna discuss some effective ways of being successful in learning, right? So, as mentioned before, you can watch as many tutorials as you want, you can read as many books as you want, but if you're not behind your computer, your keyboard, and you're actively coding, you're not gonna get any better. You need to go through the mistakes, go into the headaches of trying to debug your code and where you went wrong. That's the only effective way of coding. Like you cannot get better if you don't code. All right. A good way to also start off as well is going to be using stuff like spaced repetition. So if you guys remember, middle school, high school, even college, one of the best ways that a lot of us learn is by using flashcards. So you're gonna be learning a lot of like new terms that you're not gonna be familiar with. It helps to be able to have something that you can create that you can study through, right? We have one here. It's very common. It's called Anki. Did Guillermo speak to you guys about this? Oh, where's my Anki? Oh, here it is. Okay. A way of doing the old school flashcard method is by using Anki. It's free to download, and you can essentially create decks of your own. Here we can do create a deck, and we can do example. And it's going to create a brand new deck for you that you're able to fill out yourself, right? You click on the deck you want to work on, and you can add something new. And it's going to pop up a window for you where you're able to, customize the front and the back, what it is 2 plus 2, right? 4. And it's going to add that card for you into your deck, right? And then whenever you're ready to study through the new terms that you've been learning, the new terminology, you can just put study now, and it'll run you through your flashcards. You can practice going through the stuff that you added on your flashcard until you get better. You can even rate it from how easy it is to how hard. All right, so spaced repetition, especially when you're first starting off, commands like how to use GitHub or Git on your local machine, the different Linux commands, the different terminology, all that syntax. It's going to become very important for you to go over the terminology to understand what you're actually talking about.
Can I offer a little something real quick?
What's up?
Does anybody here know what Anki is? Have you guys used it before? So I used it when I was studying some languages before. So I use it spaced up repetition, and the idea is you have the flashcards, and let's say you have a deck of 50 cards, right? And you can in Anki you can talk about how many cards you want to study that day, and it'll give you 10 cards, right? It'll give you 10 cards out of 50, and you go through and you either get it right or wrong. And then if you get it right, it goes to the back of the deck, and you won't see it for a long, long time. If you get it, if you get it right, it goes back to that. If you get it wrong, it goes to the back of the stack. So like if you get the first 5 wrong, they're going to go to the back of the stack and you see the same ones. Once you get them right, they're going to go to the back. So it's spaced repetition. The more you get it right, the less and less you'll see that card. And the more you get it wrong, the more and more often it'll bring it to the front. So it's trying to teach you these skills. So Roger was saying there is, if you have the language, like let's say it's a for loop, right? And it's the syntax for creating a for loop. And that would be the question. That's what I would put on there, right? What's the syntax in Python for creating a for loop? And on the back, you would have it, and then you can have VS Code or whatever the hell you want open on the side there because you made the cards. And so you type it up, you flip the card over. This is where, I think you got to tell it if you got it right or wrong. That's the thing you got to do. And then it'll go to the back of the deck. So you can do it for your different contexts, especially, I've done a lot of coding. I haven't done a lot of coding, a lot of the languages that we're learning here, which is what I'm excited about. It's like, and I can already see like when you go through all the different languages, every for loop has a different syntax. And they do get like all spaghettied in the brain. And this could be a good way to do it. Does that make sense? What I just said at all?
It's like a smarter version of Quizlet. So I'm tracking.
It really is,
Yeah.
and it's free, and it's just it's a free open version of Quizlet, and you can do all sorts of things and make stacks and make decks for all sorts of just whatever you want to learn.
Yeah, Lynn is absolutely correct. It's a free version for you guys. So you guys are more than welcome to use it. I used it a little bit. I think we're all different. Some of us pick it up easier than others, so I didn't need to rely too much on it. But if you guys, you guys being in the military, a lot of things that we learn, is perishable. A lot of the skills that we try to learn is very perishable, and unless you stay on top of it, it's very easy to forget. So having something as simple as Anki or your own flashcards, if you like, doing things yourself, will help you learn these terms significantly easier, and it help that information stick. Right. So if for whatever reason you can't be behind your keyboard, actively coding, and spending hours on it and debugging and whatnot, at least doing your Anki for the day will take you miles ahead of everybody else. All right, so
And the phone app's pretty sick too.
I didn't know there was a phone app. Okay,
Yeah, the phone app,
really?
it works really well.
Yeah, it's awesome. Okay, I didn't know.
There's some bugs, like learning how it works is a pain in the balls, but once you understand how it works, it's pretty slick.
Yeah, that's awesome. Yeah, I didn't know that myself, so you learn something new every day. But yeah, definitely check out Anki, try it out. And just like Glenn mentioned, we're going to be going over JavaScript, Python, HTML and CSS aren't really programming languages, but they come with their own syntax as well. So when you start switching between all these different languages, when you start working with different frameworks, it's very easy to get confused. You're trying to write in Python and you're using JavaScript syntax, and it can look very confusing, especially if you were to go in your technical interviews. The last thing you want to do is you're solving a problem in Python and then you're start writing with JavaScript syntax and you're not understanding why. It looks extremely unprofessional if you're mistaking your languages, and it's a very common issue. So ensure that knowing the different syntax and memorizing it, Anki will help you bridge that gap in your knowledge and ensure that you don't have these issues. I say that because that happened to me, right? So don't learn from mistakes, right? So Anki, awesome tool for spaced repetition. Another tool here that you see is going to be active recall. Another way of calling it will be like rubber ducky, rubber duck programming. Has anyone ever heard of that?
There was something in CS50 in the pre-work about a rubber duck. I didn't get it. Kind of, I don't know.
Yeah, so I'm a firm believer, and I think this is very true, is that if you can teach it to somebody, it, right? If you can speak about it and talk about it, in an educational manner, you can actually teach it to somebody else. It only reemphasizes the fact that you're understanding the knowledge, and you understand like the bare foundations of it. Like, how it works because you're able to teach it somebody else. And active recall is a form of that. So one thing that programmers do, which is very common, is the rubber duck method. And it doesn't have to be a rubber duck; it can be whatever you want, right? But having something there and speaking to it, right? Do it behind closed doors so your wife doesn't think you're crazy. But speaking to something and trying to explain it to your rubber duck, what your code is doing, will actually help you realize the mistakes that you've created in your code. As you're trying to explain it, you're gonna run into something like, oh, okay, that's not supposed to be there. That's why it wasn't working. So allowing yourself to speak to something else, even if it's an inanimate object, will allow you to recall certain information, catch mistakes, and it'll help you re-emphasize that knowledge and set a much stronger foundation for you. All right, so active recall, get yourself a rubber duck, or just speak to the wall. But speaking out loud and talking out your thought process will take you a long way. So active recall, a great tool for learning how to code. Anki class demo, we just went over that. As you saw earlier. So why is it important? Resetting your forgetting curve every day. Right. So as you guys go through the program, you're going to be given a fire hose of information. Right. There's gonna be some days where you feel like it was way too much, and if you don't go back and cover what you've learned in the past, you're gonna forget a lot of it, right? So you can sit here Monday to Friday, listen to his lectures and code along, but by Friday, I guarantee you, the stuff that you learn on Monday won't be as solid as you think it is. So it's always good back to reset your forgetting curve and touch up on previous material to ensure that you understand it. So doing stuff like Anki, going back to the previous terminology, stuff that you've already learned, to re-emphasize what has been taught, will help you, solidify that information in your head, so you're not just dumping it as you're learning new information. All right, and it says here, at least when you're starting out. So obviously, as you progress through your career and your journey through software development, you're going to get better, and a lot of these things are going to stick. But when you're first starting off, like it's important that you're. Sorry, my dog's just biting me. Go away. It's important that you go back and you study up everything that you're learning. It's going to be a lot. You guys are going through. I'm pretty sure every single one of you guys are going through the full stack immersive program. Yeah, there's people that specialize on front end. People that just do back end. And they get very good at one thing, but you guys are going to be very well-rounded individuals, learning from start to finish of how everything works and being able to dabble on a lot of stuff. So it's going to be a lot of information, and ensuring that you're able to reset that forgetting curve, going back and re-emphasizing the stuff that's been taught in the past will make you learn better and understand everything in the future. It'll make it significantly easier for you, especially as you come to the end of the immersive program and you start, applying to jobs and getting interviews. It's going to be important that you remember everything. By the time we get to like the 4th or 5th assessment in the immersive program, I guarantee you, if you go back and you try to, for example, I believe Postgres is one of the much earlier assessments. The database, one of the more earlier assessments. By the time we got to the very end of the program, I had to go back and touch up on my Postgres because I forgot all the commands of how to work on a database. And it's very easy to forget it all, right? Everything that we learn is very perishable. So re-emphasizing all that previous knowledge and resetting that curve will pay dividend in the end. 2 qualities you must develop. All right, so we discussed 2 important strategies for learning how to code. Now, there's gonna be times where you're gonna be coding all day, right, from start to finish. Class is gonna start, I believe, like 8:30, and then lecture will probably be done by like 1 p.m. And after like 1 p.m. is over, you go into your group work or your solo work. You're working on the assessments, the assignments that are being given to you, or you're working on personal projects, group projects, and you're gonna get burned out, right? You need to know when to say like enough is enough, right? There's gonna come a time where you're gonna be looking at your screen, and you're not gonna be able to realize what you're reading anymore. You're gonna be burnt out. So knowing when to step away from your computer, it's important. All right, because there's gonna be moments where like you're not soaking in any more information. You're forgetting stuff. You're making newbie mistakes. And I've come to find out, if you just step away from your computer, give it 30 minutes, go eat something, watch a little bit of TV, and come back. Typically, by the time you come back, you'll solve that issue that you were encountering, right? You'll probably be able to actually recollect what you were trying to remember, or find that issue that you were doing. Sometimes even a good night's rest is enough. I would go to bed at 2 a.m. I'm banging my head all night long because I just couldn't solve an issue. And then somehow in my dream, I think of the answer. And then the next day I wake up, I go straight to my computer and I solved it. So being able to step away from your computer, wait to say like, I'm done for the night, it's going to be very important for you guys too. So make sure that you guys, don't bust your head, try to cram all this information and get hours and hours and hours on end if it's not doing anything for you. If anything, it's going to be very to be a waste of your time. What's the point of putting extra 3 hours if within those 3 hours you can't even take in any information, or you can't even focus anymore? So make sure you guys are able to step away from your computer, reset for the day, come back the next day and reassess and engage that issue you're working with.
Hey, I want to share a story real quick, Roger, because
Go ahead.
it's kind of like combining 2 things you just talked about, which is the rubber ducky and the stepping away. So when I was going, I took a assembly class long ago.
Wow.
And I was going through it and I was beating my head. It's not that hard. It's like any other programming thing. Everyone thinks it's cool, but it's just like you learn the syntax and you do it. But I was programming a microcode processor and we were doing it, and I'm beating my head against the wall and it wasn't running. And it was giving me an error. It was not doing anything I was supposed to say. I went through it. It was like 4 a.m. and I just went to bed. I woke up the next morning, got a cup of coffee, was not looking forward to this, literally sat down, looked at the piece of paper, and I didn't put a colon. There was it was $00, and it's supposed to be like $00 and that was it. Put the colon in there, and it ran. And I spent like literally 10 hours, like tired, sweating, freaking out. Like that is a true story. And then the rubber ducky part was I was like walking through it. I was looking at the code, talking my way through it with a cup of coffee, but it was like the third line down that I noticed. It was like, and I looked at that third line like 50 times the night before. I just did not see, missing that colon. So if you feel stressful, it really is like, just let it go.
Yeah.
And
No,
put it in the back
course.
of the mind too. Let the mind do its work and regenerate.
You start getting tunnel vision. You start missing, simple stuff like, you forgot a period here or a colon there. And it's something as simple as that, man. And then, it helps to be able to step away, come back, and then you'll start seeing those issues. They'll start popping up like lights. So make sure that you're able to step away. Don't burn yourself out. But yeah, another thing. If you're like me, I wanted to always get ahead. Right? I was constantly like looking at next week's material. I would like find different stuff to code while we're going through, the Python course through the immersive program. I'm like over here learning how to make games with Python on the weekend. Don't do that, right? Whenever you guys do go through your immersive program, I highly recommend, use the time that's been allocated for you guys to focus on nothing else but the material that's being taught to you, right? Once you complete the program, you can do whatever you want. Go and learn everything you want to do, work with all these different framers, whatever you might want to do, and start branching out. You can do that. But you have this allocated time from start to finish during the immersive program. You have your set curriculum. What I recommend, stay to that curriculum. All right. I was out there building games when I shouldn't be building games. And then we get to next week, and instead of re-solidifying all the information that was taught to me the week prior, I'm forgetting certain stuff, and it was a really bad habit of mine. So for you guys, tips to success, just focus all your attention on what's being taught at that moment and become a master at that before you try to move on to other things that you don't need to be doing. That's going to make you more successful throughout the program than trying to, branch out and do other things. All right, so highly recommend just stick to what's being taught. Be a master at that before we even move on. You got to put in the work. All right, as mentioned before, if you're not behind your computer coding, you're not going to get any better. All right, you can, all these classes can be Zoom taught. Right, you're gonna be behind the camera just like we are now in this exact type of environment. And it's very easy to just be on your phone while the teacher is instructing or not coding along, and that's gonna show. Right, it's gonna show once the assessment come and you're like, I don't remember this part, or I'm forgetting this, or I'm struggling with that, yada yada. You gotta put in the work. No one's gonna tell you anything if you're on your phone. Like, we don't care. At the end of the day, like it's for you guys. We're still doing our job, but you gotta put in the work, right? If Eric here is coding 8-10 hours a day, but Cody's over here getting 15 hours a day. He's coding on the weekends. He's doing all the assignments. He does the, let's say the assignment's in JavaScript, but after he completes in JavaScript, he goes back, redoes it, but in Python now. Like it's gonna show, right? Eric decided I'm gonna go and drink with my buddies on the weekend, right? Because we ain't got nothing. But Cody said, I care about my future and I want that job once I graduate. It's gonna show. So, make sure you guys put in the work. That time's allocated for you guys. Make the best of it. And it'll help you out in the long run. All right. The belief that you can do it, super underrated for adults. I didn't really grow up in a good household, but depending on you guys, if you guys receive that motivation growing up, like you can do whatever you set your mind to. We don't get that as adults anymore. No one's telling you, hey, Sam, like you can be whatever you want to be. You want to be national, go ahead and do it. No one tells us that anymore. All right, and as you go through the program, you're going to encounter something that we call imposter syndrome. And we'll talk about it later in the lecture. But you're gonna feel like you don't belong. There's gonna be moments where you might think to yourself, like, what am I even doing? Like I'm wasting my time. Like I'm not getting it like everybody else is. Raven over here is like building whole programs. We're only halfway through the course. But I'm still struggling with how to do print world. So you're gonna feel like you don't belong, and that's okay. Every single one of us goes through this journey at a different pace. And some of us it clicks faster than others. But every single one of you guys can be successful throughout the program. And if you really want to do it, you'll make it through it. Just stick to it. Imposter syndrome. I was just speaking about it. Who knows what imposter syndrome is? Anyone ever heard that term before? What's up, Lynn?
It's like you said, you don't belong. It's the idea that you don't belong. People are smarter than you. I have a really bad case of this. You know how I broke it? I just talk a lot now. I once you understand that you're the biggest dumbass in the room, then you can just say whatever you want, and even if you're wrong, it's okay. But it's that feeling that you don't belong. You're an imposter, right? I'm a fraud.
You think you're not good enough, like you shouldn't be
not
where
good
you're
enough.
at right now.
Yeah. And I mean, the truth of the matter is that everyone probably feels the same way, and no one's afraid to say it. And so as soon as you just all let it out there, it's a lot easier to be like, well, I'm a dumbass. And then, if everyone's calling themselves a dumbass, then you can always look at the goal too, what you're doing and what they're doing well, and giving some gratitude and some accolades to see what people are adding to the sauce.
Yeah, so I'm gonna tell you guys right now, imposter syndrome never goes away. It never does, right? You're always gonna feel like I probably shouldn't be in the position that I'm at. Like I'm not as qualified as I should be. Other people know more than I do. And realistically, they might. But software engineering is so diverse. There's so much. There's always new technologies coming out, new languages, new updates, new frameworks. Nowadays everything with AI. It's so diverse. Don't compare yourselves to everybody else, right? You are where you have to be at that moment that you are in, right? And if you are where you're at, don't think it was just by mistake or by fluke. You earned that position. You earned to be here in this program. And you're just as capable as everybody else in the room. And if you feel like you're struggling, and closed mouths don't get fed, so speak up. Say, hey, Roger, I have no idea what you said. Like, explain this to me. We can go to the side, and I'll get you up to speed. But every single one of you guys belongs here. We're just at different parts, right? So don't worry too much about it. If you struggle with imposter syndrome, just know that you didn't just get here by accident. All right, every single one of you guys went through the assessment. You guys put in the work to have some form of a baseline to get here, and that's all we need for now. For the rest of the course, as long as you're trying and you're making the effort, you belong here. Okay.
Excuse me. During the main course, I know this isn't FOP, but do we have 2 instructors during the immersive portion?
Who's speaking? I don't know.
Brandon.
Sorry, maybe my window's not big enough. So through the immersive program, you're going to encounter maybe 3 different instructors.
Okay.
Depending on what's being taught, they tend to kind of like rotate depending on the subject. Some are better than others. You'll have one instructor that focuses most of his career doing back end. There's one that he loves front end, so he does front end. You encounter 4 instructors. One is very into data and working with a database, so he'll teach you guys that too. So you have 4 different instructors. You have the main one, which is gonna be Francisco. Awesome dude, very patient. Like this guy, I don't know where he gets his patience, man. Like he was a prior Marine. That's probably where he got it from. But the dude's awesome. He will work with you. You will spend an hour, 2 hours, even 3 in a call with you if you're struggling. He doesn't get annoyed or irritated. He's an amazing teacher. He'll be your primary instructor. You got Adam. He kind of like dabbles in everything. Benjamin, who's like your front end expert. You got I forgot his name for the fourth instructor, Umar, source the database. He's a little funny guy. And you'll know when you see him. He's a much younger, very smart dude. Maybe doesn't always explain himself the best, but all your instructors are professionals. They know what they're doing, and they're more than welcome to help you out in anything that you're struggling with. So, yeah, I won't be there for any of that. I just teach FOP. Give me a second. Let me take my dog out because he's crying. I'll be right back.
So what services y'all in?
Space Force.
Actually,
Yep. I
Oh,
was
cool.
in the Air Force until I think 2021.
Space Force.
Yep.
You
I
know,
did this. I did the
when
same.
the-
I'm June. I
when
joined in June.
they brought that up a few years ago, I was like, this has got to be a meme. And then I was like, wait a second, it's pretty cool. All right.
That's awesome. All right. Moving forward, can you guys still see my screen, right? You guys still looking at my slides? All right, next one. So disclaimer, I didn't make these slides. Guillermo was the original instructor for Foundations of Programming. He made a lot of this, the curriculum is based off of what he made. He decided to put David Goggins here. I personally like him. I don't know how some of y'all feel about it. Not everybody is a fan of David Goggins. But they had asked him, about imposter syndrome. Does he have it? He said, no, I just worked through it. Right. So, take a page out of David Goggins' book. It doesn't exist. All right.
He's lying. Watch his stuff, man. He has the biggest case of imposter syndrome. If you listen to him talk, but sometimes you gotta have that mindset.
Yeah. Okay. But yeah. All right. So, don't worry too much about install fest. We'll take care of that in a bit. It won't impact anything you do. Cody, were you able to install VS Code? You're muted, brother.
Yeah, I didn't even try yet. I was
Yeah.
just listening. I mean,
It's
I
fine.
don't
Well,
think it'd be too difficult to do.
No, we'll take a minute, a break in a bit anyway, so no biggie. Independent classwork and questions. Don't worry too much about this. This is from the previous curriculum. All right, so the terminal, Git, and GitHub. All right, it's gonna be your first actual official lesson. Now that we're done with the introduction, rules and standards of the class. So, what is the terminal? A place where you can type commands that cause action, also known as the CLI or command line interface. Every single one of you guys with a computer has one. Who are you guys? Anyone not comfortable using terminal yet? Yeah, I remember when I was like younger, before I got comfortable with a computer, and you would think like the terminal was like what hackers use. Very very naive. Don't be scared of the terminal. Everything that you can do on your computer, you can do it through the terminal. You're gonna be getting very used to the terminal. To run, open up all your files, folders, adjust restrictions and whatnot. So for the most part, every single one of you guys if you guys have a Mac, you're probably gonna have like a ZSH. If you're on Windows, you probably have an Ubuntu terminal if you went through the install fest. It's gonna be pretty much your badge. It's where you're gonna run all your commands from. Right. So the command line interface versus the GUI. What's a GUI?
It's what you see that's not the terminal.
Graphical
Okay.
interface.
You can't answer the question with the question. Yeah, of course, right? So it's the opposite of what the command line interface, right? So it's a graphical user interface, right? It's what normal people use. It's used to make technology easier for most of us, especially if you're not technology savvy. Looking at the terminal can be a little overwhelming. Sometimes you don't want to type something wrong. You think that it might break your computer. So, the graphical interfaces are created to give you, much nicer picture and easier to navigate. So you can open up your Safari, your messages, all these applications. You can open every single application through your terminal. But most people, normal people don't know programming languages. They don't know how to type into the terminal. They don't know how to navigate it. So the GUI helps bridge that gap from someone that's not technology savvy, and the technology who here isn't comfortable with computers. I know typically we do have some people here who like never really messed around with computers before, and this is like the first time during the course. Anyone here? Okay, yeah, that's good. You know, during my class, we had a dude who never really messed with computers. You know, the job he did in the military wasn't technology based. Before that, he never really had a computer in his home. He went and bought a brand new MacBook for the class, which by the way, you guys do not have to do any of that. And a typical computer will really work. But yeah, you know, if they don't have any experience with technology, it might seem overwhelming. So that graphical user interfaces allow it to make it easier for you, right? Kind of very similar to something like Wix. You guys use Wix before? Anyone created his own personal website? You know, Wix was or is something for normal people to be able to create their own web applications or websites, right? Whereas for us as software developers or engineers, when working in a corporate environment, a corporate setting with much bigger projects, you know, somewhere like Instagram, Facebook, you need software developers that are able to manipulate every single part of your application from the bare foundation. Whereas someone who's just running a small, you know, bakery business, they can use something like Wix because it has that graphical user interface to allow them to do the basic stuff of setting up their own website. You know, that GUI assists them so they don't have to learn everything from the ground up. Making sure you have a terminal. On Mac, you can search the terminal, and for Windows, download the Weasel. That's done through your the install fest. But that's pretty much what it looks like for Windows and for you Mac users. I myself never really owned the Mac, so yeah. All right, so follow along, common terminal commands. We're gonna go ahead and open up our terminal here. I have my pinned to my taskbar. You guys can do that too, or you can look it up on your search bar, right? And open up your terminal. We're gonna go over some of these basic commands.
We
And start-
totally don't have to take a break right now, but
Oh,
it
my bad.
just seems like or feels like a
Yeah.
good moment to do that.
No, that's perfect. Thank you for reminding me, Lynn. You guys more welcome. Please stop me too if I go over time. I encourage it. Time is 6:22. Let's go ahead and take a 10-minute break. Come back at 6:33, and we'll continue with the lesson.
Can I borrow you for a minute, Roger? Because I want to try something.
Yes.
So I have a Linux box.
All right, let's come back. So we left off with the terminal commands. All right, so go ahead and open up your terminal. I'm gonna close out some stuff.
In VS Code or just in like terminal on the box?
Just open up right now. The actual terminal itself. Don't worry about VS Code yet. But for you guys that have your Weasel, you might have, if you didn't set it up to be your default, you have to go here and choose your Ubuntu. So when you're in your terminal, we're gonna go through a couple of these commands. The very first one that you see here is gonna be your working directory. It's gonna be very simple. It's just to tell you exactly where you are at. Knowing where you're at whenever you're working with your terminal is gonna affect what you do, right? So you're gonna encounter issues sometimes, and it's very common starting off. When you're gonna try to run your program through your terminal, and you're gonna have some issues where it's not gonna run, and you're gonna be wondering why. And the reason for that is because you're not in the location of where your program is at, right? So for example, right now I'm in /home/r/12, right? But I had a program within like inside here, within like documents, within like Python, and then like, you know, inside my Python folder, I had my program like, you know, example.py, and I try to run it from where I'm at right now in the current directory. I might have an issue because it won't know where the file is at. So you can run it from where you're at, but you would have to specify the location specifically of where your program is located at. So knowing where you're currently at in your directory will solve that issue. So it's also important to know where you're currently located in. For example, if I wanted to go into my coding here, I have a bunch of different folders. If I wanted to run something within like the FOP folder, I want to go into it. So as you see, as I start diving deeper into my folders, it starts adding it onto my directory. So right now I can see that I'm inside of my Linux coding. If I wanted to go into FOP and I go inside of it, it starts adding it to my current working directory. All right, so it typically shows you where you're at, but if you are struggling to know where you are at, you can use pwd and it'll tell you exactly the path that you've taken so far, right? And within home, within this user, within Linux coding, within FOP. So that's what that does. We're going to go to the next one, which is going to be mkdir, which is make a directory. All right, this is going to be the command for creating a folder within your terminal. So let's create an example. So we can do make directory, and I'm going to name that folder example. This will create that folder within the area where I'm at in my directory. And I can use a command ls to list everything within the directory I'm in. And we can see here, we have, wait, I just create an example right here. All right, so we have the example folder inside here. So I know it created within it. When I use the command mkdir example, we didn't see it give me any kind of feedback. So what does that mean? Well, whenever we're working with our code, typically if you don't receive any kind of message back, it tends to mean that it worked, right? If you ever really have an issue, it'll tell you like your computer will yell at you like, no, this did not work, right? Or whatever. So no feedback is good feedback. So that's your make directory. You see me use a couple commands here. The next is going to be cd, which is going to change directory or move to a different folder. So right now, if we look at the current working directory I'm in, I'm within Linux coding. I list everything within here, and I'm going to go into the new folder that I just created, which is going to be example. So to go in there, we're going to use a cd command, followed by the name of the folder I want to change into. And we see here, it adds it to my working directory on the left. Within Linux coding inside of example, I can use ls to list everything within this current folder. It doesn't return anything because it's an empty folder that I just recently created. Right. Here we see other versions of cd. We have the cd followed by 2 dots. That's going to be to go back up one directory. So when you're thinking about your directories, think of it as like you're diving deeper within your files. So the double periods will bring you back up a level from where you're at. As discussed prior, I'm currently within example. I can use cd ... and it brings me back up to Linux coding. And I have all my other folders here. All right. cd with your little curly thing will bring you all the way back up to the very top. All right, so instead of trying to like cd ... all the way up, you can use the little squiggle and it'll bring you back up all the way to your home directory. So we covered how to make a folder, but how do we make a file? It's going to be with the touch command. I don't know who created that one, but that's weird. But it's going to be touch and then the name of the file that you want to touch, right? Weird. So we're going to go into, let's see, go back into Linux coding, example. And then within here, I'm going to want to create a file. So I'm going to say touch, and I'm going to create a Python file. I'm going to call it example1.py. We didn't receive any feedback as discussed prior. No feedback is good feedback. We use the ls command. It's going to list everything within this directory, and we see that our file was created and it's in here. Pretty straightforward. Everyone with me? Yeah, just go work through it with me as you're messing with your terminal. Kind of start getting used to how to go in folders, out of folders, making a folder, making a file. The next one here we have on our list is going to be the ls. This is to show all files within a directory. As I just showed you guys earlier, we can go into the FOP folder. I put ls, and we have a bunch of different folders pop up from what I've had prior. I have the typical lesson you guys are gonna have. I have my own answer keys that I've created. Don't worry too much about that. But ls will show you everything within that working directory that you're in. Here we have an extra command to the ls. We have the ls-l, right? And that's going to show you all the files within the directory with extra info. So this is too big. Let's go into example. ls. Okay, so we have that file we created, and we can do ls-l to list that file I have in here. And we see here we have some extra items in here. We have the name of the file, example1.py. To the left of it, we have the time and the date of when that file was created, and then who it belongs to. On the far left, we're going to see some weird letters and dashes. This is going to be the permissions that you have within this file, right? We're not going to dive too much into it, but essentially it's 9 different characters, 3 sections, each made of 3 different permissions. The R is going to stand for reading. The W is going to stand for writing. So from here, I can see that the permissions I have is I'm able to read this file as well as write into it. The third one is going to be your whether you're able to execute it, right? If I remember correctly, each one stands for something different, whether like, yourself, the next 3 is going to be like groups. Don't worry too much about it. You're only going to use this once within the immersive program, and it's going to be to SSH into your web application once it goes live. But it's nothing to worry too much about it. Just know at this point, it's the permissions that you have within this file, right? Next command is going to be ls-la. It shows all files with extra info, even if they are hidden. Sometimes you have those hidden folders. This one shouldn't have anything, but we'll go ahead and do it. Right, so we have the example1.py. We have some extra hidden folders here that we didn't create, that were created automatically when we made the folder. They're hidden for you, and they have pretty much very similar makeup times to when I created the folder itself. Don't worry too much about it. RM removes the file. So right now, if I wanted to remove the example file I created, I would do RM and then the name of the file I'm trying to remove. No feedback is good feedback. We go ahead and list everything within this working directory, and we see that it no longer exists. But for the sake of explaining the next part, we're going to go ahead and create it again. Touch example1.py. It's in here again. Let's go ahead and back up. I list my folders in here within my Linux coding directory. I see example folders in there. The next method is going to be removing a folder. I think I have to delete it, but we will do rm-r for recursive, and then the name of the folder you're trying to remove, ls to list it, and we see that it no longer exists within our working directory. All right, so that's how you're going to remove a folder. All right. If I'm correct, let's go ahead and make that folder again. And then see the example. Let's touch 1.py. If it has a file within it, and I try to delete that file without the -r, it's going to give me an issue. Right? It says cannot remove example is a directory. Now, the reason why it doesn't want to remove it is because I currently have a file that lives within it, which is where the -r comes into play. Essentially, it's telling the computer, hey, remove everything from the bottom up. by force. So you're removing all the files within this folder and then removing the folder as well. So if you ever try to remove a folder and you don't add that -r and you have files in it, you're gonna get that issue right there where it says it's a directory and you can't remove it. So instead of going in there and manually deleting every single file, you can just do the -r and it'll delete it completely. Use it sparingly so you don't accidentally delete something that you didn't want to delete. It's happened before. So far, so good. Any questions on what we just covered real quick? We're gonna go very quick with this. This is mainly to expose you to these commands. You don't have to be proficient at it right now. Just want to make sure that you guys are aware of the very common commands you can use within your terminal to start allowing you to navigate it effectively and start getting ready for the immersive program. But if you ever have any issues of what command does what, you can always just Google these. There tends to be a cheat sheet that people make where there's like all of them laid out. So very easy Google find. The next one is going to be sudo. All right, so you guys already kind of experienced this within the install fest if you guys did it. Sudo is going to stand for super user do. All right. So if you guys ever try to run a program and it says like you're now like the administrator or whatever, like there's certain things that only a super user, the owner of the computer, can actually manage to do. And the reason for that is to protect you from accidentally, adding something to your computer or deleting something that might be important to your computer. So if you don't need whatever you're trying to delete, or if whatever you're trying to install is safe, we typically try to use sudo just to override any kind of restrictions you might have and just install what we want. You saw that a lot within the install fest. Whenever you installed it, your Postgres, Python went out. We use sudo for a lot of these commands, just so you can override any restrictions. Cat is going to concatenate your files. The rest of these right here that we're going to go over, you're not going to really need to use much. It's mainly just expose you, allow you to know that these exist. But this will concatenate different types of files and show them to you. Nothing too crazy. CP is going to allow you to copy files or directories and their content into a different folder. So let's say you wanted to move all the contents of one folder to another. You would create and grab everything from one folder and move it to another using the CP method. You probably won't use it too much. Moves the file or renames it. It's another way of doing it without creating it and copying and pasting. You can just go ahead and move a folder from one place to another or renaming it. Finding a file somewhere. You would go into the directory you're trying to go to. Let's say you have like hundreds of files in there. You can use the find and the name of the file you're trying to find, and it'll locate it for you, making it easier for you. Grep allows you to search by word or character match. If you're not exactly sure what that file is actually called, you can put something close to it, and it'll find you everything that matches like that. Is anyone here familiar with regex? You guys work that during the pre-work? Yeah, so grep kind of works a little bit like regex.
Did you say regex?
Regex, regular expressions.
Okay.
GIF, whoever you ask, they'll tell you differently. But yes, regex, yes. It's very similar, right? So you create a pattern to try to find certain things within like your strings or whatever you're searching through, and it'll find you whatever matches it finds, right? That's pretty much what grep is doing. It's using the very the exact type of methods. Change mod, change the files, rewrite, execute permissions. This is referring to the permission I showed you earlier on the file. Whenever we listed the other contents of the other information within the file, like the name when it was created, the owner of it, that those dashes and different letters that you had in the far left. This is going to allow you to change those restrictions. The way it would work, you would do chmod and then you give it some kind of number combination. It tends to be from 1 through 7. And every number means something different. Like 1 will mean like you can read, but you can't write or execute. 2 will be like you can write, but you can't read it. Like certain stuff like that. Every different number will give you a different combination of the type of permission you can give for that file. You don't have to worry too much about it. Just know that that is how you change the restrictions on your files. Ping, you can check if a network or server is reachable. You probably never have to use it either, but it does exist. We can do something like ping google.com, and it'll check if that server's up, right? It's whatever you're trying to locate is currently on or working. So it just pretty much pings it. It's like using your Find My Apple Watch, but yeah, something very similar to that. Next, you're gonna have history. It's gonna show your terminal history. So here I type in history, you can see every single command I've been using since we started this class, in order from how I used them. So if you did something, you typed in some command, you don't remember exactly what you typed in to get to where you're at, you can type in history and it'll give you the log of all the stuff that you have done. Yeah, pretty straightforward. Echo is to display a line of text using standard output. It allows you to like say hello on your terminal. Won't really need to use it too much. But as mentioned before, these are mainly to expose you to them. You don't have to be proficient in all these. The biggest ones that you're going to be really using are going to be the first slide, right? All these are going to be your commonly used commands that you'll probably use on your day-to-day life while going through the immersive program. So if you had to focus on things to ensure that you memorize, definitely the first slide. Not too much of the second one. It's helpful to know, but not needed. But there's obviously dozens of other commands out there, but the other commands are going to be relevant to the immersive course. But this will get you from point A to point B for now. All right, so common terminal command still clear. If you guys haven't seen what I've been doing as I've been going through here, I've been removing everything that I've been putting on my screen. And the way to do that is by using the clear method. It'll essentially delete it from your screen. It doesn't mean that it didn't happen or it didn't execute. All you're doing is you're trying to clear up your screen to give you some breathing room so you can focus on what you're trying to actually execute or look for. Especially if you've been putting all these commands, if you just looked up the history, now you want to get rid of it out of your screen so it's not bugging you. The clear method will do that for you. Pretty straightforward. Tab autocomplete in the terminal. So if I wanted to go into my FOP folder, I typed in F. After that, press tab, and it will autocomplete to the closest thing that it's going to match to, which is for me my FOP folder. So tab allows you to save just like that 1/10 of a second of typing it out. It just autocompletes it for you. A nice little helpful tip to know. Control C is going to terminate a running command. How many of you guys have created infinite loops? Yeah, I bet you have, right? Command C is going to be or Control C is going to be your, the way to stop that. So whenever you create something on your terminal, just running nonstop, if you want to halt it, just stop it completely, just terminate whatever you just did. Control C will allow you to stop all that processing. Control Q, undo a terminal freeze. I use this whenever I run something on my terminal and it's like active. If I just want to exit out of it, for example, if I were to initialize Python within my terminal and I start coding in there, Control Q will exit out of there. It'll remove it for me. That's where I use Control Key a lot. Remove RM-RF removes the folder, even if it has protected files. Be careful. So very similar to how we did earlier with a -R, but this one is specifically for any file that might be protected from being deleted. It will completely override it and just remove everything complete. So use it very sparingly because it's an easy way to lose all your stuff. And the last one, this one you'll use a lot, is code and then the name of the folder. So this is going to be how you're going to open up your VS Code from now on. Let's close this up. If I wanted to open up my VS Code, let's go to, I forgot, is it updates? I want to open up the FOP folder within my VS Code. I would do code, the name of whatever I'm trying to open up in VS Code. Or if I wanted to open just everything within this directory, I can use the period, which stands for all for you regex users. You know, the period typically stands for everything. So code all will open up your VS Code with everything within this directory. We see here. It opens it up, my VS Code. So this is how you're gonna be opening up your VS Code for anything that you want to use. Avoid opening up VS Code directly, looking for the file or folder right now, especially for like Ubuntu users. When you install Ubuntu, what it's gonna do is gonna create like a what's the best way of doing it? Like a small version of your computer, but in like the corner of your computer, if that makes sense. It's going to allow you to separate all your coding stuff that's done to Ubuntu from the rest of your other documents and files. It's almost going to create like a small container of your work, and trying to find your Ubuntu work normally through like looking through your files or documents can get very confusing if you try to find the exact location of it. So it's always easier if you just use your Ubuntu shell and you start from this working directory and then just open up VS Code from there. Trying to find it from here can get very confusing. It also depends how you set up your VS Code. So just use your terminal. This is how you open up all your VS Codes.
So question real quick on code. My understanding just playing around is that you can also use open to just open a file, but if you use code and you don't already have that file in your system, you are creating a new file. So instead of using touch, you could do like code test.javascript, and it will create that file for you and also open up VS Code essentially.
Yeah, you can.
Okay.
Yeah, code is just the alias that VS Code uses when you install it onto your computer. So when you type in code, it knows it's referring to, it's paired with VS Code. So your computer knows you're opening up VS Code. It's the command specific for VS Code. So that's
Okay.
where code comes from. Yeah. So here you also see a little side note for the code command. Above to work, you must do the following: go to your VS Code, view command palette, and then add it to your shell commands. So install code command in your path. Right. So if it's not working for you, try it out. You probably just don't have it set up for your default command path. Any questions? Sweet. Cody, are you able to do all this? I'm assuming not. Like the opening code.
No, I mean I didn't create the. Actually, let me
That's
try
fine.
it real quick.
You probably won't. These are Linux commands. You're using
Yeah.
your regular terminal.
I'm in
There
Mac,
is.
yeah, so I haven't partitioned out Ubuntu yet.
Oh, I mean Ubuntu won't. You don't need Ubuntu for Mac. Mac is Unix based. We
Okay.
use Ubuntu for anyone that doesn't have a Mac. It kind of puts us on the same playing field, so we're able to still use Linux commands while using a Windows. So that's the point for Ubuntu. It's mainly it's just for our Windows users. If you have Mac, they should work.
Okay, it looks like it opened. I just
Yep.
created example 1.py and it created it. Yeah, I can use the code command.
Sweet. All right, so practice the Linux commands, write them into your Anki deck would help. I mentioned before, there's obviously way more commands than themselves, but this is enough to get you guys started. Kind of get your feet wet with working with the terminal, so you're not as scared of it as I was when I first started. You're not gonna break anything. Just don't do anything crazy, like remove recursively everything within a folder or whatever. Here you see, feel free to customize your terminal however you would like as well. There are tutorials on YouTube that allow you to do it. I didn't really care for it, but if you really care about what your names look like in color, by all means. I do believe there might be some guides on lesson 1. Let's see. No, you can probably look it up. I didn't try to. I thought it was a waste of my time, but you're more than welcome to experiment with your terminal. All right. Next, what is Git? So I'm sure you guys have heard the terms Git, GitHub. Oh man, I already reading it. Who can explain to me the difference between Git and GitHub?
So I think Git is like, I forgot what it stands for or what it's actually for, but it's like a repository where you can kind of review the files that are kind of coming in, and someone can like approve them, and then you can actually put that into like the source code, and then GitHub's kind of like where you get all those files and stuff or whatever the source code is at the time.
Yes and no. You're on the right ballpark, but you're not exactly right. So Git and GitHub, they're you know, they work together. Git's gonna be your local repository. So everything that you have within your computer, what you have access to on your computer, that's gonna be Git. GitHub is your remote repository. That's the actual GitHub website, right? Where you can go in there and see different repos, create repos, download repos. The GitHub website itself, GitHub in general, and its servers, it's the remote repository. Git is your local repository, everything within your computer. So they both go hand in hand. One is what you have yourself personally on your computer, one being the remote version of it, right? Anyone want to explain to me the reason for GitHub or Git in general?
I mean, my understanding is that Git is software, it's repository, and then GitHub is using that same software and, you know, all the interaction Ghibli bits so that people can collaborate, and it's a lot of open source, you know, sharing things, being able to do open source or have a common place and make your branches and go backwards and keep your versioning and all that, you know, good stuff.
Yeah, so those are one of the features of GitHub, yeah. GitHub is, you know, at its simplest terms, a form of version control, right? So we wanted a way to be able to track, you know, our projects, our work, and then ways to be able to update it without affecting our current work. And at the same time, being able to have different collaborators to be able to contribute to the main project, right? And GitHub allows you to do that, right? GitHub essentially will hold what is known as like the master branch, the main meat and potatoes of your project. And it gives you the ability to create little branches to the side where you can add changes, you know, updates, and then merge it into the overall main tree, right? Your master. So you can kind of see that here from the diagram presented to you on the slides. We have you know, the green dot is going to represent your main branch, your master branch. This tends to be the default master. This is what's going to be like the main, the number one version of what your project is going to be, right? This is like its final product, what it should look like, right? But whenever you want to create an update, you want to have a change, we want to be able to still have what we have right now, and not lose it, but at the same time use what we have and kind of deviate from it a little bit, make some changes, and then add those new changes to the main branch. And you see a small little description of that here on your work and someone else's work. You know, the main tree itself, the master branch, that's where the main source of the code is at. But then people are able to create a copy, a clone of the main branch that they can work on, and then bring it back in and merge it into the main branch, right? Without affecting any of the major code. And that's what GitHub does for us. It holds our what we call repositories, which is just like a fancy word for like, you know, like a storage, right? It holds like our main programs. And then we can create branches within the repositories that we can download onto our computers, or create on our computers. We can make those changes and then upload them back up into GitHub and combine them. And then everyone else can download your new changes, pull from there, and everyone can be on the same page. But it allows you to make changes and updates without affecting the main branch itself. Right. So
Question when it
Yeah,
comes to Git versus GitHub. So I know on if your local system, and I know if you do like you remove a directory or something, it's gone. GitHub, let's say some junior dev like inadvertently somehow deletes like the master branch or something. Is there something in place on GitHub that either backs that up or prevents that from happening permissions wise?
So first and foremost, if you're working with like a big company like that, they're gonna have restrictions on you, right? So there's certain things that you're not gonna be allowed to do to prevent that exact thing, right? So if someone were trying to push a change into the main branch, first and foremost, if it's done right, they shouldn't even be able to, it won't allow you to, right? Whenever you're gonna make a new change, you're gonna update, right, your work, you're going to create a branch, right? It's going to create like a copy of what the main branch is. And then in that branch, you're going to make your changes, right? You're going to update it, you're going to delete this, delete that, add this, add whatever. And then once it's ready to go, you're going to push it up to GitHub, right? GitHub is going to receive that change in the form of a branch. And then you're going to put in what's called a pull request, right? You're requesting for someone to pull the changes you made and add it into the main branch. That pull request is going to typically, the restrictions are in place, is going to require for you to request someone to review your work, right? So you'll have to request typically from like your lead, someone with more time and experience than you do that knows what they're doing. They will have to review their work. It will show you what used to be there and what is now there side by side. And it'll tell that lead what files you deleted, what you added. If you deleted or removed anything, it will be in red. Anything you added will be in green. And they're able to see side by side every change that you created. And then they're going to review it, ensure there's not any conflicts for your branch. And when they give the thumbs up, hey, it's good to go, they're going to approve your pull request. And then that will allow it to merge it into the main branch. So typically, even if you wanted to do something with the main branch, like there would be restrictions in place so it doesn't happen. I know you've probably, if you guys started following all these Instagram pages about software developing on Instagram, you've probably seen like these memes, whatever, like when you push into the main branch or whatever, like you deleting the main branch and causing a mess. Has it happened in the past? Yes, it has. But it's not something that happens too often, unless whoever received your pull request wasn't paying attention and they approved it and then messed everything up. Right, that's where it typically tends to happen. But yeah, so that's kind of how that works. Any other questions? Is everyone like understanding that?
No, that was a good explanation. Thanks.
Awesome. All right. Moving forward, so why do we use Git? In times past, this is from Guillermo, right? If you think back to when you guys were in school and you had a project you're working on the school computer, but you wanted to be able to take it home with you so you can edit it at home or continue working on it. You would download it, create a copy of it, or save it somewhere else on a USB so you can take it home and work on it and then bring it back and make your changes when you get back to school. It kind of removes those extra steps. That way you're able to work from somewhere else, make changes without actually affecting your main work. That's where that slide's getting at. So Git solves these problems. It provides save points and possible backups of your code should you need them. Right. So whenever you add a change, you commit something to your branch, it's going to record all that. Right. It's going to record it. It's going to have some kind of like a hash code to represent the location of this change. You're able to use these hash codes to kind of find the changes you've made. It essentially creates a log of all the changes and updates that have been created within your branch, your main branches, and you're able to track all that very effectively. When I was going through the full stack immersion program, we got into group projects. My group project decided to go the unorthodox route of not doing a full stack project and we decided to create a game. We created a roguelike RPG game using the Godot game engine. Now Godot is not as big as Unreal Engine. It doesn't have all all these cool features. It was fairly new to GitHub. I don't know if it still is, but when we started working with Godot, it didn't have the best compatibility with GitHub. So whenever we would upload our changes to GitHub, there's so many times where our files were being corrupted. Right, I was in charge of making the main protagonist, our hero, and whenever I made a change on the hero, the person in charge of making like our map was using my hero that I created. They would implement my hero in the map, but whenever I created a change on the hero, the map wasn't registering the changes and it would corrupt the files. So we did a lot of work. Like the amount of times I had to redo my entire work because of that is insane. I probably recreated that hero 5 different times. And there are times where the entire main branch was just corrupted. So we had to go back and look through all these different commits, figure out which one was the issue, figure out when was the last time that we had a working branch using the codes that GitHub creates in the snapshot. So we found the version that brought us back to a time where our code was working and it wasn't too far back where we lost too much work. And it was very helpful being able to have be able to track all these things so we can go back to a state of time where we weren't losing our work, where stuff wasn't messed up. So GitHub Git is amazing. It allows you to go back to a point where your code is working and you didn't ruin everything. So it's fixable, and GitHub gives you those tools. All right, a structured example in Git. So we're gonna go ahead and go to GitHub. Repositories. All right, we're gonna create a I haven't done this in a hot minute. Our repositories. We're gonna create something new. Right? Make sure you guys follow through with me. It's easier to learn. GitHub is easy to forget if you're not actively working with it. So try to follow along with me. Who here does not have a GitHub account? Okay, so instead, let's go ahead and take a 15-minute break. We'll start now. That way we get some time for those that don't have a GitHub account to register, create one, and at the same time, take the 10-minute break afterwards to use the restroom, get a cup of coffee or whatever you need. And then when we come back, we can all continue on and code along or work along on GitHub. How's that sound? All right, cool. Let's come back at 7:30. Was everyone able to get their GitHub up? Okay. No one's gonna have any issues, right? Who already forked the repo? Nobody? Okay, good, because it just got
Which
updated.
repo? The
The,
FPO, the FOP repo?
Yeah, FOP. It just got updated. We'll talk about it right now about how to pull. Okay. Let's go ahead and resume. Share screen. All right, so going back to creating a repository. Let me make sure I'm still on track. Instructor example, Git. All right, so we'll go through it real quick. I don't know if it's gonna change, but all right. So we're gonna create a new repository. So back to where I was at to make sure everyone's on the same page. You're gonna go to your repository area. On top right, you can have the option to create new. There's a little book icon there. and you click new, is gonna bring you to this window, right? At the very top, you're gonna have who the owner of this repository is gonna be. Just put yourself, and then you can name it whatever you want. I'm gonna go ahead and call this cat memes. All right, it don't matter what you call it, but just for the sake of the example, name it whatever you want. You don't have to give a description. I would say a GitHub example. Just keep it public. You're given the option of adding a README. You don't have to if you don't want to. Not mandatory. I'm just gonna keep it by itself. The next option is gonna be adding a git ignore. The git ignore is a little bit out of like the scope of this class. But git ignore essentially is it creates a file that allows you to add what files your GitHub should immediately ignore whenever someone pushes up something into GitHub. So what does that mean? Well, there's going to be some times where you're going to require, sorry, my kid's crying in the background. You're going to require like special keys that only you as a developer should have privilege to. And you're not going to want to send that up into GitHub because when other people fork your repository, they would have access to stuff that they shouldn't have access to. So git ignore gives you the option of adding certain things that it would not take in whenever you create a, when you push up into GitHub. So that's what git ignore does. You can add your keys into a specific file, and then whenever you need to use it, there's a certain way you can go around it and use the keys without having it in your repository. So out of scope, but just know that that's an option. And then the license, don't worry too much about it. Ain't nothing here need to be licensed. But you're gonna create this repository, and as it creates, it's gonna bring you to the screen. Essentially, this is just a setup screen that's going to walk you through how to connect your GitHub to your local Git on your virtual machine. All right, so here, I fingered it. I'm within my update folder. Let me go ahead and get out of here. I'm gonna go into I deleted make directory example. I'm gonna go inside my example folder. It's empty, and we're gonna work from here. All right. So within here, we don't have anything just yet, but I'm going to create a new file. It's going to be example.py. It's going to open up my my VS Code with the new file I created. And then as you see here on my terminal, I'm in the exact same location of my working directory that I was in my terminal. Actually, I'm in updates. So, I know what it did. Don't save. Sorry, I had another VS Code open. All right, so when I open it up, it should bring me here. Is it not in here? What's going on? I didn't open it. Oh, because I didn't save it. My bad. Let's go and just create it. Touch example.py. So whenever this is back to what Eric had brought up earlier. You know how you mentioned you can open up a file or you can do code and then the name of the file and it opens it up for you. If you don't save it after you open it, then it's not going to save it onto that folder. So that's what happened here, right? I did code example.py. I opened up my VS Code, but it's not in here because I never saved it when I closed it up. So I created that file. I know it's in here. Now I can do code all. It's going to open up this directory. And we'll see here on the left side, it's loading up a little bit. There you go. But because I actually created it, I didn't just open up an empty file and not save it. Now it's actually in here. So this is going to be the example file I'm going to use. I'm going to link to my empty repository. So I'm gonna do something as simple as print repository example. I'm opening my terminal. We see here my working directory. I'm within my example directory. That's awesome. All right, cool. I can run my Python file, and we see here it prints out repository example. Now, this is what I'm gonna want to link up to my repository, right? This is my project that I've been working on. You know, whatever it may be, you're creating some kind of calendar or whatever, music app, whatever it may be. This is the file you now want to send up into GitHub. So after you have your working project and you want to link it to something, you would come up here, create the repository in the same manner that we did. But now we want to make sure that these two bad boys are talking to each other. And they do that for you. They gave you exactly what you need to put into your terminal. So with my VS Code, within this terminal, I'm going to go ahead and walk step by step through these examples. Don't worry about the first one. That's about the README. It's not important. What really matters here is at the part where it says git init. And maybe it'll be better if we talk through it. Okay. We're going to essentially initialize our git and link it all together, right? So before I get ahead of myself, so up to this point, you guys are understanding, right? What is GitHub? The difference between a local repository and the remote repository. All right, that's the difference between both Git and GitHub. Everyone understands what GitHub is, right? Cool. So we're gonna have some commands that we're gonna need. The commands that you saw on the screen are provided for you. It's pretty much a how-to for every single time you create a new repo. That'll provide you with them. But we're going to discuss a little bit of the commands so you have an idea. Git has specific unique commands. And how do you have these commands now? Well, if you went through the install fest and you added the VS Code, once you install the VS Code, it should have added these Git commands. Well, you don't just randomly have Git commands unless you added them. Install fest, where was that? Git, right? So if you went to this part, you should have installed Git into your system. I know for those of you like Cody, don't worry too much about it. We'll cover it. But this is how you essentially install Git, and you're able to use all the different commands that you get from it, right? For those of you who aren't there, don't worry too much about it. We'll take care of it at the end of class. But one of the three top Git commands you're going to be using is going to be git add, git commit, and git push. All right, so whenever you're working with Git, you're going to want to, after you create the changes in your project and you're ready to get them ready to send them up to GitHub, git add is going to stage all the changes that you created and it's going to put them to the side, right? Essentially, whenever you do git add, it's going to review all your files, it's going to see all the changes, and it's going to stage these new changes on the side, ready for you to push them up, right? This allows you to not have to send up every single change that you create on your project. So whenever you're ready to stage something, you use the command git add, and the dot is pretty much like everything else. It signifies all. This will receive all the files that you have. Any file that has received a change, it'll stage them in a staging area that you don't see, right? Just know they're on the side and they're ready to be sent up. If you wanted to only send one file up, instead of using the dot, you would specify the name of the file that you want to stage, and you would do git add and then the name of the file. All right. But git add and then the parent will stage everything that you've updated or changed and place it on the side ready for you to send up. Git commit -m is you sending it up to GitHub. So now that you've already made all these changes, you stage them on the side. Now you're ready to push them up. You're going to call what we call, you're going to commit them. So you're going to grab them all and you essentially like package them up, and you're going to put like some message in there to tell whoever you're sending this up to what changes you made. So you would do git commit, the -m is the command to let you write a message. After -m, you're going to do open and close parentheses, and you can put in whatever message you want to put, like, hey, I updated the the JavaScript file, by adding a button, whatever, right? So you can put whatever small little message you want to send up to whoever's going to be reviewing your work. And then once it's been packaged, ready to go, you add the memo you want to add to your commit. You're going to push it up, right? And that's where the get push command comes into play. And this will send it up to GitHub where you will receive the change. And we'll cover that. It will make more sense as we actually go through it. These are the Git commands you're going to be using. The Git init is going to be to initialize Git wherever you're working on, right? So Git doesn't just magically start up. You have to tell it to start up, right? You have the commands, you installed it already to the install list, but now you want to turn that bad boy on and let it know, hey, I'm ready to track progress in my project, right? By initializing Git, Git would now start tracking any change you create onto your files. If you don't initialize Git, it won't be tracking any of your changes. So you're gonna do Git init, it starts it up, and it will now start taking snapshots of every single change you add on your project. As discussed previously, Git add, and then the name of the file will add that file to a staging area, right? The Git dot adds all the new changes or files to the staging area, so you can either specify or grab all of them. Git commit adds everything in the staging area to the special folder as a snapshot or commit, right? So this special folder, you're not going to see it. It's one of those hidden folders that your computer tends to just hide, so you don't see it. You can actually look it up in your documents. You can actually find a Git folder where it adds all these things. It's not really needed. It's out of scope for this. Just know that whenever you commit it, it's pretty much staging it, packaging it up for you in a certain location before you send that bad boy off. You're gonna have another command you can use. It's gonna be get status, and it's gonna show all the files in the staging area. All right, so if you don't remember what you've staged, if you've been staging it, folder file by file, like because you're not gonna commit everything, you're able to use get status and just double check what do I have right now in my staging area. Get rm cached is going to remove stuff from that staging area, right? So you can specify specifically what file you want to remove from there. Get log is going to show you a history of your snapshots or commits. So it'll tell you all the changes you made and every single time that you committed up to your GitHub. And then get push is the final green button that's going to send everything that you've already done up to GitHub because it's ready to go. Like you finished working, you've made all the changes, all the updates, and you're ready to send it up into GitHub. And we'll work through that real quick so you guys can understand. So back to my example here. This is my project, right? The simple file, a Python file with the code print repository example. And I'm going to go ahead and I'm going to initialize Git. And what do we see here? What is it doing? So you see a message here, and pretty much it says initialize empty Git repository. So at this point, nothing's talking yet, right? My Git repository is different from my GitHub repository, right? Remember, Git is local, GitHub is your remote. So here I started an empty Git repository in my local machine. And all it's doing is going to start tracking all the changes that I create, right? And it's going to create a branch for me. Typically, this branch is called either master or main. And if you want to check your branches, you're going to use the command git branch. Oh my God, I don't know why it's doing this again. We'll do it in a bit. For some reason, these last couple of days, some of these commands for GitHub haven't been working. So don't worry about it too much. But you're able to check what branches you have. And it'll make more sense once we start creating other ones. But essentially, it'll create a branch, which is going to be your master branch. Here you see names commonly chosen instead of master or main, trunk, development. You mainly see master or main. Mine tends to be just main. But it'll create that branch for you. We can actually go ahead and just create it now. We'll call it main. Git branch main. No, it's still not doing it. That's unfortunate. Anyways, so we initialized our GitHub. It started an empty Git repository and is now tracking all our changes. So let's go ahead and check out the step-by-step. So we initialize it, cool. We're not going to add a README. You can. All it's going to do is going to create a file like you see or you saw all my other stuff, like on the repo, you see how these folders have different readmes. Essentially, a readme is just a brief explanation of what your project is, how to install stuff, any kind of notes you want to give to anyone that's downloading your repository from GitHub. You can create a readme that allows you to brief that person on your project and anything that might be important. Like, hey, like, this project requires you to have this installed or whatever, or this version of this. Hey, you need to have version so-and-so of Django or React for you to be able to run this project, right? Readmes tends to have like stuff like that that's important for the user. But we're not going to get too deep into that. We don't need a readme for this project. So we're going to skip that step. We're going to commit, or we're going to add and commit our first change. So now that our Git has been initialized, we're going to stage your stuff. We're going to do git add, and we only have one file, so we can just do period to add everything in there. And we didn't see any feedback. We can do git status, and we can see everything that we've done so far for the staging area. We see here we're on branch main, no commits yet, changes to be committed, and we see everything below this is going to be the staging area. All right, we have one file, a new file called example.py. So when I did git add in the period, it staged all my changes into the staging area. It doesn't show you visually, just know that it is happening behind the scenes, right? And if you want to see the staging area and what's in there, you would use git status. As you can see here, it's currently there within the staging area. Right, so it's within the staging area. I'm going to want to send it up to my repository on my GitHub. So I'm going to commit it. So git commit -m for a message, and then I'm going to give it a message. It's going to be first commit. Very similar to how the description told us. You can do whatever you want here. It's just an example. So we're going to commit our very first change, and it's going to give us a message here. We see here it has some kind of code, different letters and numbers, and then it shows the message that we added within the parentheses. We see we have one file change and one insertion. All right. We created example.py. So it's essentially saying what is different from what our git status was before. Well, now we have a new file, right? This is what has changed. So we committed that. Let's see if we can do the branch now. Git branch m main. See the branch. Yeah. Okay. So now we can see the branch. Right. So we create the main branch. We can see the branch we have here. If we wanted to have a separate branch, we can do that too. To create a new branch, you would git checkout. You want to check out a new branch, and then you'll call it whatever you want. So we can say file branch. Git branch, file branch. Git branch. Okay, there we go. My bad. Checkout is going to be for you to check out other branches that you've already created. We create the new branch here, side branch, and whenever we use the git branch method, it's going to list off all the new branches we have. And we see here we have a main branch and a side branch. We don't have to really worry too much about the side branch right now. The main thing is we want to focus on main. So we have our main branch, and now we want to connect our branch up to the branches on top of our GitHub. So to do that, we're going to ensure that we're on the proper branch we want to connect. So we already checked it. We did git branch. We see here the asterisk next to main. That means we're currently working on our main branch. And now we want to add it and connect it to our GitHub. So we're going to do git remote add origin. And then you're going to do a copy and paste, right, of the location of where our GitHub repo is located at on the GitHub. So do git remote add origin, and then we just copy and paste the location of it. No feedback is good feedback. So now what did that just do? Well, all we just did right now was connect them. Now they're talking. Now my local repository knows that the main branch I have here is going to be connected to the main branch on my GitHub repository. That's all I just did. Now that they are talking, I can finally push up to it by using the git push method. Git push to origin main. It's going to go through some little commands here. You're going to see here enumerating objects, 3 done. It counted through it 100%. And it was successful. Branch main set up to track remote branch main from origin, right? That's saying that, hey, the branch main I have here in my local repository has now been set up to track the remote branch main from my origin, which is going to be on my GitHub, right? And it sent that bad boy up. So if we did this correctly, we should be able to go to our cat mains repository, and we see here that we successfully pushed up our file. All right, and then to the right of it, we see the message that came with it, first commit. We're able to open up this file, and we see here the code within this file, right? And it's exactly what I had in my VS Code, parent repository example. Up to this point, I was able to successfully link my local repository to my remote repository on GitHub, and I was able to successfully transfer my work up to GitHub, right? Is everyone still with me? Any confusion at all? Speak
Yeah,
now.
that was kind of a fire. That was kind of a fire hose, but I got kind of stuck on the very beginning where you had like the quick thing, and then I didn't get the link after I made the repository myself, and I was like just kind of trying to look for like if you accidentally exit out of like that quick, what is it, that quick setup thing? Like how do you get to that?
You should be able to go to your repository and go to code, and you'll see this little thing pop up. You'll have different versions of how to use that repository. If you go to HTTPS, this link right here,
I see it. Yep.
just click copy URL to clipboard.
Okay, and then just put that in whatever you just
Correct.
did to get that in there to update. Okay.
Don't worry, we're guys gonna get the chance to go through this too. So I know it's very quick, but we'll go through it, and you guys can all try it out yourself if you didn't do it completely, and then we'll fix any issues. So
the other question I had really quick too, sorry about that, was difference between it might be getting too much into the weeds right now, but you kind of lost me at like main and branch. Is just main like the main code that you'd be working with, and the branch is kind of like the off code, like, and that's where you're kind of get the object oriented programming, right?
so not even about object oriented programming. So on the main stuff, the different branches, right? So main is just another way of saying master, right? So like as you saw on the message, it goes by different terms. Typically, it's either master or main. Jesus, that's bright. Typically, it's either master or main. Like they go by different names, but just know that they're essentially the exact same thing. That's what you call the main trunk of your GitHub. Like this is your main tree. This is where all the meat and potatoes, what really matters, like your main project, it lives within main or master, whatever you want to call it. Right? Whenever you want to make changes and not affect your main branch or your master branch, you create, a branch, and you can name it whatever you want. And you saw that whenever I created this other branch called side branch, right? I was able to create a separate one if you're about to see how these are different. But this is essentially a copy of this branch. And that's how GitHub and Git is very useful, because you're able to create copies of your main work. I can go to my side branch, make work there, and it won't affect my main branch because there will be two separate things, right? It makes a clone of what your current work is or whatever branch you decided to branch off from. It makes a clone of that. That way you can make work without affecting the main branch, right? Everyone still with me? All right, you guys will get some time behind the computer too. No big worries. Okay, so let's go back to it. So I now know that my main branch in my local repository is talking to my remote repository. All right, they're connected thanks to that setup we just did. I was able to successfully send up the work from my local to my remote. Now, let's say I want to change something else, right? So I was able to print the repository example, but now I'm going to add more code, print more code, right? It's just for demonstration purposes. Now, is this the same thing I have in GitHub? No, right? Because sure, are they connected? Yeah, but there's ways for them to talk, and that's by adding, committing, and pushing my changes. Right now, my GitHub repository, it's still the same. I haven't sent anything up here new, right? It's only tracking what I sent up earlier throughout my last commit. So my local repository, I can continue making changes, and it's not going to affect it until I send the changes up. Right, so I created something new, right? I added more code, I made updates, I made changes to my local repository, and now I'm ready to ensure that the main version control of my main branch is up to date with what I have on my own computer too. So I made changes. I'm going ahead, I'm gonna add these changes to the staging area. By git add, I'll just use the dot for all of it. I'm gonna go ahead and commit, hit commit. And I'm gonna say added new changes. Oop. All right, I'm gonna commit those changes. And we now see here, we added a new change. One file was changed, 3 insertions, 1 deletion. I don't know what the heck we deleted, but yeah. So it's gonna give you a description of what has changed from what you had before, right? It's gonna check the main repo on your GitHub. It's gonna check what you have locally, and it's gonna tell you, hey, you changed one file, you've added this, you deleted this, right? So now that I'm committing, I can push to my origin main, right? Origin being like where my GitHub is originating from, which is the cat memes repository I have up in the cloud in GitHub, main being to the main branch. Right, so it goes through this little thing, and it was successful, and it made the change. So now, if I come to my GitHub, I can refresh it. We see here added new changes 1 minute ago. We can open up that file, actually look at the changes, and we see here that line 3, the changes that I had in my local repository are now updated on my remote repository on GitHub. All right, pretty cool. Right, and that's how GitHub and Git work, right? GitHub is a location on a remote, in GitHub and some servers somewhere that they're able to track all your changes, and you're able to update it from there or grab changes from there, and you're able to manipulate different versions of it so you don't lose it all. For example, if one day I'm trying to make an update on my project and I absolutely mess it up, well, my local repository is messed up, but what can I do? Well, I can just go ahead, I can there's different commands you can do to like rebase back to a certain state. Honestly, my way would be just delete everything I got and just get back what I have on my repository on GitHub. I can just delete my version of it. I go to the repository on GitHub, I clone it, and now I have the old working version before I messed it up, right? So essentially, it's like a save point. It creates a save point for you on GitHub that you're always able to reference and use and build off of, so you don't ruin your entire project. And if you ever do ruin the entire project or mess it up, GitHub allows you to go back to your previous state where it was working, right? Yeah, so let's do something else. We can create a new file in here. I'm going to call this second example.py. Print. This is my second example, right? I added a new file to my project, right? I'm adding new stuff to it. I'm creating assets and folders, whatever you want to add to your project. I'm ready to send this bad boy up, git add. It adds it to the staging area. We can see that by going to git status. And on the staging area, we see a new file called second example.py. Right, so now we know that it's staged. Let's go ahead and commit this. Added a new file. It commits it, right? So now it's in that folder, ready to go, packaged up with a message, and now I'm ready to git push origin main. I'm gonna send these bad boys up to my remote server. We see here the success messages that we get, what it went through. We can come back to our remote repository, and wow, look at that. Added a new file now, right? We can see the second example.py file is now being tracked on my remote repository. Open it up, and you see the code in here, right? So as you start building on your project, you can update what you have on GitHub to ensure you always have the latest version of your working code, right? And as you build different applications and programs, you start working on your solo projects, your group projects, it's gonna, it would be do good for you. It would, I don't want to use the word, it would behoove you to use GitHub, to actually the smiles, to track your progress, ensure you always have the most up-to-date version of your project. And in case you ever make a mistake, you're able to go back to a certain point where your project was working. So that's the wonders of GitHub. Now, let's say you're working in a group, right? Both me, Eric, and Sam are all working on, this e-commerce website. My main role is to work on the homepage. Sam is working on the transactions, whatever. Eric's maybe working on like our gallery or whatever. We're able to separate the workload. He's able to create different features while I work on the feature, and we can all contribute to the same project using our main branch from our GitHub. We can create different branches. One being like, oh, this is the checkout branch. This is, the gallery branch, whatever it may be. As you make changes, you can all work on the same project, but work with different versions and slowly start adding it into the main branch. And whenever, let's say Sam is done with his part, he can update it to main, and then I can just pull his changes and add it to the versions I have. And it just, collabs together, and we can all work on the same project without interfering with each other's work. If there's ever any kind of corruption or issues with your files, typically GitHub will kind of tell you to, if they're like very obvious. It'll tell you if there's any like conflicting issues. But also it's up to you guys as the developers to ensure that whenever you do a push up to your branch, and you put in a pull request to merge the branches, that you go through the code and ensure there's no conflicting code in there that might ruin everything else. But that's how GitHub works, Git works, how it works to work in team, the branches, and how it comes into play. All right. Next. All right, student practice, push to GitHub. We'll take about 15 minutes to do this. Time's gonna be 8:04. Let's take till 8:20. Let's look at that real quick. Push to GitHub. So if you look on, oh, we haven't even done this yet. Okay, my bad. All right, so let's take this time and let's actually fork or clone the curriculum for FOP. So in your slides or in your calendar, you're gonna find that link that I mentioned when we first started, right? Go ahead and click that link, and it's gonna open you up to the GitHub repository for the curriculum, right? All the lessons that you're gonna be using. All right, when you open it up, you can go to the top right where it says code in green, and you click on that. You can do something very similar that Sam and I just did. You're going to copy the URL to the clipboard. Now, for you to be able to receive this copy, you're going to go to the location of where you want to have this FOP curriculum. So just create a folder, call it, FOP curriculum, whatever you want to call it. Once you find the folder, if you guys are looking at my screen, you're going to do git clone, and then do Control V, right? What that's going to do is going to clone the entire repository from GitHub onto your local machine. All right, so find somewhere in your terminal, in your directory, somewhere you want to have the curriculum, and that's how you're going to clone the entire repository. Let me know if anyone has any issues. I'm not gonna do it because I already have my own version. All right, but that's how you essentially clone a repository. So that project I was just working on, right, with all my example.py, my second example, you guys could do the exact same thing. You can go to that repository. I can send you a link, and you can clone my work and bring it down to your local machine and receive a version that won't impact mine, and you can work from there as well. You can have access to the work I've been doing.
Have you ever worked with the GitHub CLI before?
Are you talking about Git Bash?
It's the like I just saw it recently. Basically it's like a brew install where you can use the GH command for all of your GitHub. Basically everything we're doing now.
You can. It allows you to. Not needed.
Okay. I was trying to get your perspective on it, like if it's actually like a better thing or if it's just like, something they're pushing for marketing purposes or whatever.
I would say maybe for if you're working with an actual software company, because this is like very low, low stress environment. Like we're just doing very small stuff, like small little files, not needed. You don't have to. You can if you enjoy it. But this is all you will ever need for the rest of your time in Copeton. Any other questions? Okay. Yeah, so we just saw how to do that. Let's check out the readme for this. All right, so we have a git pair assignment here. We didn't do it last class. I forgot why we didn't do it, but I'm gonna allow you guys to try it out. It can get a little bit too advanced. Don't worry too much about it. Essentially, you're gonna pair up in twos, right? You guys can choose who's gonna be A or B. And then one of you guys are gonna create a repo, right? It doesn't matter who it is. You're gonna fork that repo to yourself. You're gonna create a text document called story. You're gonna commit and push up and just mess around with GitHub a little bit, right? A will add B as a collaborator on the repository. So I want you guys to just kind of experiment with it. Where is my? So if you go to, where's that? Let's say, is it settings? Oh, this on how many? Pull requests. No actions. Where was the collaborators part? Stand by. Let me figure this out real quick, and then we can split up into teams.
I think you go into settings.
Oh,
and
my
you go to
computer.
repository.
My computer just froze. Oh, I hope it doesn't freeze, because then it's gonna ruin the recording. Can you guys hear me? Hello?
Yeah, I can hear you. I got you.
Yeah, I can hear you.
My Zoom just froze, so that's unfortunate. I hope it doesn't mess up the recording. Can you guys see my screen though?
Yeah, if you're still on GitHub.
Okay,
Yeah.
thank God.
I
All
can
right, that's
see
all that
cat
matters.
memes.
So collaborators. Hold on a second. I gotta get my code. All right, so you go to collaborators within that repo you're in. You can add people. You're gonna require an email address. Add yourself as collaborator so you guys can make changes to your repos. And just go down these different exercises, right? So you can, forking a repo, making changes, creating a branch. So forking a repo is essentially what we just did. We just kind of very similar to like cloning, but you can fork it to your own computer. Let's see, let me go back to it. Fork your own copy of so-and-so. You can press it, and then you can go to the same thing tool, add it to your GitHub. So you can go through that. It'll give you a copy for you to work on yourself.
Your screen isn't doing anything.
Oh, that's unfortunate. Okay, I'm gonna have to leave the Zoom call. Or not the rest of the hours that we're doing. So be right back. All right, sorry for that, disturbance. I don't know what happened with my Zoom, it just froze. But yeah, back to what I was saying. Take some time to go through it, mess around with some GitHub. If you want to fork something on the top right, you go to the repository you're trying to fork, you press fork, and then it'll allow you to fork it to your GitHub account. So you can have you can mess with it. So that's how you fork. Kind of just mess with it. If you guys have never seen it before, it's nice to just kind of try all the different things that GitHub has for you. So try doing that. Make changes, create a branch, add each other as collaborators. Pull. We can do git pull as well before we actually continue. Are you guys seeing my screen? So we did discuss the branch earlier. All right, if we go to make sure it's initialized, git branch. I'm at the project I was working on. Remember we created that side branch? Well, what happens if I switch to that branch? Who can tell me? Anybody? No guesses
If
or
you
what happens?
switch what? If you
So-
switch like the side branch to another branch, is that what you're
No,
asking?
so right now I use git branch, right? And git branch, we know, gives us a list of all the branches that exist within our local repository. We see here we have the main branch, which is the main meat and potatoes. And then at one point when I was giving the explanation, I created a branch, right? And I called it side branch, right? You can call it whatever you want, but essentially I created a different branch that isn't my main. Here on my terminal, you can see an asterisk next to main. That's telling me I am currently working on my main branch, right? So if you want to switch over to a different branch, you're going to do git checkout, and then the name of the branch you want to switch to. What's going to happen when I switch to my side branch? What happens to all my code?
Does it just go away because you didn't really save it?
It
The
goes away.
repository?
It goes away because my side branch isn't tracking what my main branch is tracking, right? Because when I recreated the side branch, my main branch didn't have this second example.py yet, right? I created my side branch when it was just example.py, and it was only one thing on here, which was the repository example. So whenever I switched over to my side branch, it went to that state of when I created it, and it's not tracking the other changes, right? So now if I were to go back to main branch, so git checkout main, we see here the changes. They just populated on my screen. My main branch had that, on line 3, print more code, and it's also tracking that we have an extra file on my main branch. Back again, let's see it one more time. Git checkout side branch, and this is the status of my side branch. It doesn't have that change I had created. It doesn't have that file, because when I created the side branch, it created a clone of the state of the branch that I was branching off from, right? At that moment when I branched off, it didn't have all these changes. So my side branch is outdated, right? It's at a different state than what my main branch is currently located at. So let's see, let's do something like print side branch. I'm gonna go ahead and git add, git commit, side branch update, git push. And here it's telling us the current branch side has no upstream branch. Why is that? What is it telling me? Any guesses?
Oh, there's no branch in the GitHub repository.
Yeah, when I created my main branch, we specifically connected the main branch to the main branch on GitHub, right? Those two are talking. My local main branch and my remote main branch are talking. But if you remember, this right here, my repository on GitHub, this is all it's tracking. On the top left right here, this is your tab to check all the branches that you have. I can open it up and it shows me my branches. It's only tracking my main branch. It's not tracking a separate branch because Git, my local Git, has that branch, but my remote GitHub doesn't. Which is why whenever I switched over to my side branch here on my local machine, it gives me an error, right? It says that there's no current branch that's located upstream. So it does you a favor. It gives you the command for it. Git push set upstream origin and then the name of the branch. And it goes through its little, process. We see here created pull request, whatever. Point is now it should be tracking my GitHub. So if I go to my GitHub, if we do this right, side branch had recent pushes 14 seconds ago. So now my GitHub is tracking that branch I had created in my local machine, right? So just because I do something on my local machine, like the changes, updates, or even creating a branch, I have to make sure that my GitHub is actually tracking these changes. It wasn't tracking my side branch before, but now it is. Now there's another branch here, and it's talking to the branch at on my local, right? So cool. Now they're talking. Now I can do a git push. Git push origin side branch. Up to date. Did he send it up when I sent it? Let's check it out. Okay, yeah. So when it created that branch and connected them, we see here it's tracking what my side branch is tracking, example.py. And it's the print side branch code I had added. Well, I have two branches now. That's an issue. And we got a new message on top that says side branch has recent pushes 1 minute ago. Compare and pull request, right? So why is it doing this? Well, because I worked on my main branch. I added a file, added some changes. I also created a side branch. There are two different versions of my code at two different states. But now, I have to decide, what am I going to do with these changes? Am I going to pull them together, or should I just remove the side branch, right? The main branch is what really matters, right? That's your main thing. That's your, your ride or die. That's what has everything for you. Side branches typically have like side projects, any features you want to add, any updates, and they're done that way you don't impact your main branch. So now I get to decide, hey, are these changes valid? Is this what I want for my main branch to look like? Well, let's check it out. Let's go to compare and pull request. And it's going to bring us to this little window where it's going to say open a pull request. You can add a title, whatever you want to call this pull request. You can add a description of any changes that you are trying to make for the main branch, right? So whoever's gonna be in charge of you, your lead, your boss, whatever. Whenever you put in this pull request, you go up here, you start it, add a title and description what you're doing, and at the bottom is gonna show you what you're trying to pull in. As mentioned before, it's gonna show you a left and right description of what is the difference between the main branch that you're trying to pull into and the side branch that you're trying to push in. We see here the difference between the example.py was that this one didn't have the side branch. I'm going to be removing this file completely, and then I'm going to be adding this. So what's red is what's no longer present, and what's green is the new changes. 3 additions, 1 deletion. Let's go ahead and create pull request. Checking for ability to merge automatically. This branch has conflicts that must be resolved. Conflicting files, example.py. It gives you the option to resolve it. And the issue here is that on one, it has print side branch, and the other one, it has print more code. So you can actually you can do manual changes here to what you actually want to see done. Remove all conflict, right? So it added this side branch, a main branch to show you the differences. It's showing me here, hey, on side branch, you have this code. And then it has the equal signs to show me where it's now being separated. And now on your main branch, you have more code, right? So you have to choose, what do you want to do? Well, I'm going to keep side branch. And I'm going to remove more code. These are warning markers, so you have to remove these manually. And then we can see mark as resolved, commit merge, and it begins merging your changes. Right, it brings you back to this window. This branch has no conflicts with the base branch, and we're good to send it. We can merge pull request. I'm the only person on this bad boy, so I can just go ahead and confirm merge right off the bat. If it wasn't just you and you had other collaborators, it would tell you like, you need permissions from so-and-so, yada, yada, or you would have to wait for someone else to do it. You wouldn't even get the option to merge it. But here we see pull request successfully merged and closed. Then go back to cat memes. And we see second example py still exists, right? But the only change that we have between the main branch and the side branch was the side branch was changing the example.py. The main branch still kept the extra files, right? But the files that the side branch was changing, it changed, right? I fixed the conflicts, and we now see that our example.py is different because we had that merge, right? And then once you're done, you can go ahead and delete the branches that you no longer need if you wanted to. You can go to view all branches and delete it. I'm not gonna do that yet. But yeah, so my GitHub is fixed. Let's check out git branch. We're still on side branch git. Check out main. Your branch is behind origin main by 3 commits. It can be fast forwarded. Use git pull to update your local branch. Well, what happened? Well, on my local machine, the example.py still reads this, where on line 3 it shows more code. But on my remote GitHub, we added a change, right? So we merged that side branch, and we decided to add that new change that branch had. So it's no longer the same. So if we want to update what we have to what the remote repository has, we're going to use git pull. And we see here it pulls all the changes that GitHub is tracking into our local repository, right? And that is the beauty of branches, right? You're able to create a copy of your program, your code, able to make changes to it, and then merge it into your main to update your main, right? And if there's any issues, it'll tell you where the issues are of conflict are at. Then you can resolve them. And then yeah, it updates it. But that's how you essentially add an update to your main without directly affecting your main branch, and ruining everything by mistake. Everyone still with me? Don't worry, you guys will work on it on the last 30 minutes of class. Yeah, so that takes care of that. Create a branch, making changes. It's 8:29. We're gonna take the next 25 minutes to work through this as a group. We'll break up into pairs, and then I'll flow through all the breakout rooms and give any kind of help to you guys as needed. All right. I'm gonna go ahead and pause the recording now. All right, how is everyone doing?
I failed.
Yeah. Okay, I'm gonna do a quick recap.
Bit
It's gonna
rough.
be wait for everybody to come in. All right, we're all here. I'm gonna do a quick recap of what just happened. A quick walkthrough of how to do it real quick. Some people got stuck, and that's okay. You know, it's expected since the first time you guys have been doing this, so no biggie. Let me just try to figure out how to delete this. Settings. Let me delete my repository real quick, and I can go through it. Okay.
This is being recorded, right?
Yes, it is.
Okay, I do need to head out because it is 10 o'clock for me right now. I
That's
know
fine.
missing super important, but I'll watch it.
No, it's all
tomorrow.
good. It's gonna be quick because we don't have too much time. All right, just a quick recap of how this is done. I'm gonna go ahead and create a new repository. I deleted the last one, so I'm gonna go ahead and use it again. Cat memes, no description, public. I'm not adding a README file, whatever. Pretty straightforward. It's gonna create the repository on my GitHub, right? So it's important whenever you guys create you initialize Git on your local machine, you also have to create one on GitHub, right? Because you have to link both these bad boys together. So once you create your repository on GitHub, it's gonna bring you to this quick setup stage. I deleted that past folder I had, so I'm gonna go ahead and make directory example. CD example. We don't have anything here, so I'm gonna create a new file, touch example.py. Let's go ahead and open this bad boy in VS Code. I'm going to go ahead and print hello world. So far I created my remote repository and I created a project that I want to send up to my GitHub, right? So how do we begin? Well, now that I have my project, I'm gonna go ahead and initialize Git. There we go. That was weird. Git init. Let's go and initialize an empty Git repository here. As you see, it started. So we're gonna do a step-by-step walkthrough of how this is supposed to work left and right. Let's go ahead and lower this. I'm gonna go through the commands, very straightforward. You don't really want to skip too much. You don't need the first line, but we already initialized Git. I'm not gonna use a README, but you could go to the README if you wanted to. But we're going to add our stuff to the staging area. I'm going to commit my work. First commit. I'm going to create my branch main. So git branch -m main. No good is good news. After my branch is created, I'm going to connect this branch to my main branch on GitHub. So git remote add origin. I can copy this. Essentially, I can copy the whole line if I want to, but copy it. It's gonna link it together. Now that they're linked, it's set upstream. I can do git push origin main. And we see here, it's linked it up. Branch main set up to track remote branch main from origin. I can go into my cat news repo and voila, it's there. Quick and simple, right? Two different things, having a GitHub repository and having a local repository, and then just connecting it. Now, if I wanted to make a new branch, let's check out my branches. So git branch, it tells me the branches I have. I currently have my main branch, but I want to create a new branch where I'm gonna add new stuff to it. So I can do git checkout a new feature. Git branch. Oh, my bad. Git checkout. I'm trying to check a branch that doesn't exist. We'll git branch and call it new feature. We can check our branches now to see if it exists. Wow, there it is. Awesome. So I can go and move over to that branch that I now want to use to create my updates. Go to git checkout new. I misspelled it, of course. Sorry, I'm doing this in a hurry because I don't want to take your time. I'm already above the time limit. So I switched to the new branch I want to work on. On this new branch, I want to add a new file. I'm gonna call this example2.py. Print new example. Save it. Git add. I'm gonna add all my changes. I can check my git status. I can see that it's there on the staging area. Git commit. Added a new file. There we go. It's been added to the commit area, and now I can push it. Git push origin main. Oh, my bad. I don't want to push it there. I want to. If I go to git push, it's going to ask me to set it upstream. So don't get confused what I just did. My bad. I fumbled that. But I wanted to push on my new branch that I created, right? So when I put git push, right, it gave me an issue because my main branch is connected to my main GitHub repo, but the new branch I created isn't. So it's telling me git push set upstream origin, and then I'm gonna name the branch up top. It creates that branch on my GitHub. We see here at real time, it created the new branch. Now they're talking. I can come here, refresh it. I see I have a branch here. Compare and pull requests. Add a new file. There it is on my title. Create pull request. No biggie. It's checking that there's no conflicts. There's no conflicts. Merge pull request. Confirm merge. And then I can go back to that repo. And I can check. I'm now on my main branch. And now it's tracking the changes that I had on my side branch. So I merged the side branch into my main. Now my main is up to date with a new file that I added. All right, pretty straightforward. I know that was quick. I just don't want to take too much of your time. I would hate to waste your time on a Monday evening, especially because it's Monday. But hopefully that solved any issue you guys might have had. Just follow the steps. Don't try to diverge from it because you'll just get confused. I don't have too much time for you guys today. Thank you for being patient with me, and I will see you guys tomorrow. If you have any questions, I'll stay here a little bit longer before I head out. For Cody and Len, we'll deal with your stall phase. I gotta get Guillermo to help you guys out, especially because when you guys have Linux, oh, I'm sorry, you have Mac. So I don't have my own Mac, so it's hard for me to try to help you guys out with that. So we'll deal with that accordingly tomorrow if we can. Besides that, you guys have a great rest of your day.
Thank you.
Thank you.
Thank
No
you.
problem.
Yeah, thanks. Hey, what